Okay, so for today's class, we're looking at transformations. So slides, which are translations, flips, which are reflections, turns are rotations, and then we'll also look at dilations, which are enlargements and reductions of the figures. I'm just gonna continue. We'll come back to the video after. So a translation or a slide, it's made by sliding an original figure up, down, left, or right. And each point can be slid individually, or if it's a figure, you can slide the entire figure. Some students like to use tracing paper. If you still like to use tracing paper, that's fine as well. So here we're going to plot a triangle ABC. We're given our points for it, and then we're going to slide the triangle given this notation, positive 3, minus 4. So recall when we were looking at ordered pairs, it's always x, y. So whenever we look at that notation, it's represented like x and y, like that. So that means it's positive 3 in the x direction and y in the negative direction. In our modules, you'll notice they're using R for right, L for left, U for up, and D for down. Okay, so you might see that in your modules, but you might also see this as well. So that notation means x plus 3 and y minus 4. So let's look at our point A. Our point A is at 1, 6. So 1, 6, there's point A, and we'll label it A. And then point B is at negative 5. Negative 5, up 3. There it is. And then point C is at 2, 2. There we go. So there is our 3 points, and that makes our triangle. Let me just quickly draw my triangle. So there we have it. There's our triangle ABC. And it tells us we're going to slide this triangle positive 3 minus 4. So there's a couple ways you can do this. First method is you can just slide each point positive 3. So that means 3 to the right, 1, 2, 3, and then negative 4 means down 4. So 1, 2, 3, 4. So that's where our new point will be. And you can double check that just by adding 3 to your x point and subtracting 4 to the y point. Our new point should be at 4, 2. So if we look at that, 4, 2, that is our new point, and we call it A prime. So A prime, that's our new point there. I'm just going to move the C a little bit over, not to be confused. All right, so we call that point A prime. Our next point, B, so same thing, over 3 to the right, 1, 2, 3, and down 4, 1, 2, 3, 4. There's our new point. And if we double check that by adding 3 and subtracting 4 to our x and y points, it should be at negative 2, negative 1, and it is. So we'll call that point B prime. And our point C, again, we can just over 3 to the right, 1, 2, 3, and down 4. 1, 2, 3, 4, and there's our C prime. And we can double check that. It's at 5, negative 2, which is correct. And now we just have to connect the points and draw our triangle. All right, so here we have our new triangle, or its image, A prime, B prime, C prime, which is represented by the little ones on top. So original triangle was ABC, and then this is our image. So sometimes in your module, you might see it written as O for original, and then I for the image. And as well in your modules, you might see it written as right, left, U for up, D for down. But we know if it's a positive in our x direction, you're moving right. If it's a negative in the x direction, you're moving left. For our y direction, if it's a positive, you're moving up. If it's a negative, you're moving down. Here's another example of just showing a translation. So we have our original triangle LMN. and it's -4 units in the x direction, so meaning you're moving it to the left 4 points, and then -2 units in the y direction, meaning you're moving down 2 points. So our notation is x minus 4, y minus 2. And we can see what's happening here just by moving the points. So -4 in the x direction, so 1, 2, 3, 4, and then down 2 in the y direction, 1, 2. And our new point is here, and we'll label that n prime. Here's our m, 1, 2, 3, 4, down 2. Our new point is shown here. And same thing for L, 1, 2, 3, 4, and then down 2. And again, our new triangle is L prime, M prime, N prime, shown by those like apostrophes beside the letter. So it's been, the figure has been slid to the left 4 and down 2 points. So a reflection, this is when a figure is being flipped or reflected about a mirror line, which is shown as ML. So right here, that's your mirror line. Here is the mirror line. That mirror line also then will become the line of symmetry between the two figures. So again, here, figure O is labeled. That's the original figure. There's our mirror line, and then we're going to reflect that, and that's our image. So again, you take each point over to the mirror line and the same distance to the other side. So for example, this point is 1, 2, 3 to the mirror line. So therefore 1, 2, 3 for that point. And you do that for each point, 1, 2, 3, 1, 2, 3, and then you would draw in your figure. All right, so let's see here. We have our original figure, A, B, C. It's a triangle, and we're going to flip it about the x-axis. All right, so we're going to do the same thing, count the squares to the mirror line. Our mirror line is the x-axis, and we're going to label those as prime. So for here, count 1, 2, 3, 4, 5, 6 to the mirror line, and we're going to count from here now. 1, 2, 3, 4, 5, 6. There's our new point, and I'm going to label it A prime. So our new point is 2, -6, 2, -6. Let's do the same thing for B. It's 1, 2, 3 to the mirror line. So 1, 2, 3. There's our B prime, and then C is just 1 away to the mirror line, so just 1 away there, and we'll label that C prime. Okay, and now I just have to connect the points. All right, so I've just connected to make our reflected image here, A prime, B prime, C prime, and it's been reflected about the x-axis. So one thing to note here, when we reflected over the x-axis, is our x value stayed the same, 2 and 2, -3, -3, 4 and 4, but our y values became opposite. 6 became -6, 3 became -3, 1 became -1. All right, so that would be a flip or a reflection. Here's another example showing a flip or reflection. This time it's happening at the y-axis. So our mirror line is here. It's our y-axis. So our original image is this one, A, B, C. So again, you would count to our mirror line, which is our y-axis. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. There would be our new point for A. B, count to the mirror line, which is our y-axis here. 1, 2, and then from there, count 2 again. 1, 2. There's our B prime. For C, 1, 2, 3, 4 to the mirror line, which is our y-axis. Count 4 again. 1, 2, 3, 4. There's our C prime. And then you would connect the points to get your triangle. So note here that our y value stayed the same. Our x value became the opposite. So this was when flipping about the y-axis. Okay, so next we're looking at rotations, which are turns. So this is when a figure is being turned about a specific point. So notice here, our green figure was turned. Now it looks like this. That was turned 90 degrees clockwise. So in your modules, you'll see CW. CW represents clockwise, and CCW represents counterclockwise. So clockwise is going the same way as a clock would, and then counterclockwise is going in the opposite direction. So this way is counterclockwise, the opposite direction of clockwise. Okay, so when we look at a figure, if it's being turned 90 degrees clockwise, this way, that's 90 degrees. It's the same thing as turning a figure 270 degrees counterclockwise. So 1, 2, 3. A figure that's turned 180 degrees clockwise or counterclockwise, it's the same thing. And a figure that's turned 270 degrees clockwise, clockwise, 1, 2, 3, it would be the same thing as turning a figure 90 degrees counterclockwise, so just once this way. I'll pause here, we'll have a video. So looking at the rotations then, here's our original figure, rotating it 90 degrees clockwise. It's the same thing as if you did 270 degrees counterclockwise. So notice our points switched here. Our original point was 1, 2. Our A prime now is 2, negative 1. Okay, which makes sense because it's in this quadrant. And then 180 degrees clockwise is the same thing as 180 degrees counterclockwise. Notice our point was 1, 2, and it just changes. You just change its sign, so it becomes negative 1 and negative 2. And then 270 degrees counterclockwise, so 90, 180, 270 is here. It's the same thing as if we had turned 90 degrees counterclockwise, which would be here. All right, so notice our points. Our original was 1, 2. It switches, it became negative 2 and 1, which makes sense because it's in this quadrant, negative 2 and 1. So just to sum up for rotations, if you have center of rotation is at 0, 0, our pre-image point is x, y. You can see what happens to the points when it is here rotated 90 degrees clockwise or 270 degrees counterclockwise, becomes y negative x. 180 degrees clockwise or counterclockwise, we just switch the signs, becomes negative and negative. And then if it's 270 clockwise or 90 degrees clockwise, again, it switches, becomes a negative yx. Okay, so lastly, we're just looking at dilations. This is an enlargement or a reduction. So here, when we dilate a figure, the object is going to change size, but it still maintains its shape. So it's always similar to the original figure. So all the angles will be the same, but the sides are either going to be larger or smaller in accordance to a specific ratio. So for here, our original triangle is triangle ABC, and we're told it's going to double. It's going to become 2x and 2y, so it means it's multiplying by 2. So all our original points are going to multiply by 2. So if we look at our original point was negative 4, negative 2, we're going to multiply that by 2. That's going to become negative 8, negative 4. So for point A, it's at negative 8, negative 4. Point B, again, our original point is 4, 0. We're going to multiply by 2. That gives my next point 8, 0, which is here. And point C, negative 2, 2. We're going to double it. So it becomes negative 4 and 4. So you can see it's increased in size. It's doubled. This one here, our original triangle is KLM. It has points KLM given here. And then our points are going to half in size. It says half x and half y. So if we look at what the new points will become, So our original point for K was 6, 6. That's our original point. And we're going to half that, half X and half Y. Our point for K prime will become 3, 3. For L, our original point is -8, -6. So that when we half that, that's going to become half of -8 is -4, half of -6 is -3. And then our original point M is 8, -4. And we're just going to half that. So M prime is going to be 4, -2. All right, so I'll just plot those quickly. So here we can see our original triangle, KLM, and then our new smaller triangle, K prime, L prime, L prime. K prime, L prime, M prime.